Welcome to Phantastic Physics. Today, I'm going to use this special light emitter to aim it at this whiteboard over here. I'm going to turn the lights off in just a moment. And when I aim these lights, there's actually only 3 color bulbs in here. There's a red bulb, a blue bulb, and a green bulb. So I'll be shining red, green, and blue light at this whiteboard. And I'm going to mix these colors, and we're going to try to predict what color combinations will produce what kind of result. So for example, if I shine green and blue light at this board at the same time, what color does the human eye perceive? So before I get into it and shut the lights out, I want to remind everyone that if you enjoy the content discussed in this video, you can purchase our full year high school physics curriculum by going to the link in this video description below, clicking on our store, and checking out all the great physics content that we have to offer. And without further ado, let's go ahead and jump right into this experiment. Now that the lights are out, I'm going to go ahead and turn on one of the light bulbs and let's see what happens. So the first thing you're going to notice is this is the red bulb, and so you can see red light is being shined directly at the whiteboard here. And so my next question is, okay, if I turn on the blue light bulb as well and I shine both red and blue at this bulb together, what color will we see when those two colors overlap? So take a moment to make a prediction. So I'm going to have pure blue and red light coming together in one spot, and I want you to predict what we will see. All right, so let's take a look. So interesting. When I shine the blue and the red together, you can see they overlap in this region right here. And that actually is the color that we call magenta. So it looks almost like a purple or pinkish color. So we call this magenta. And so red and blue are both primary colors of light. And when they mix together, they produce magenta, which is one of the primary colors that you will find in a printer. So one of the ink cartridges is typically going to be magenta. Okay, so let's go ahead and shut off the red and blue for a second. And so the next thing we're going to do is let's mix green and blue together. So I'm going to shine, let's start with the blue light. And so my question is, what color will we see when I mix this blue with green? So take a minute to think about that. And so let's go ahead and add the green light. And you can see a new color emerge where the green and the blue overlap. And this is the color that we call cyan. So when we mix two primary colors of light, green and blue, we get a primary color of printing as well, right? So in your print cartridges, you're always going to find a cyan, because if you mix cyan with other colors, you can produce a lot of different kinds of colors. This is a primary color of printing, which comes from two primary colors of light. Okay, so let's get rid of these two again. And now I'm gonna mix green and red. So I'll start by showing the red light. And so what's going to happen if I shine green in the same location that overlaps with this red? So what do you think is going to happen? Red plus green makes what? Let's find out. Wow. Okay, so most people are very shocked by this one. So the human eye perceives red and green as the color yellow. So when you mix red and green light, you get yellow, which is also one of the primary colors of printing. So every printer has a cyan, a magenta, and a yellow cartridge. With those 3 colors, you can actually print any color. And it turns out with the 3 primary colors of light, red, green, and blue, you can produce any other color, okay? And so we can make other colors aside from cyan, yellow, and magenta by just adjusting the intensity of the light, right? More red or more green or more yellow, or sorry, more red, more green, or more blue, you'll get various combinations, and you can actually produce an infinite spectrum of colors. Okay, so one more question. What if I shine all 3 of these primary colors together in the same spot? So we shine red, green, and blue. What does the human eye perceive as the combination of those 3 colors? Let's go ahead and add some blue into the mix. And so what do you notice? Look right there in the center. You can see the cyan, magenta, and yellow where the colors are overlapping, where there's 2 colors overlapping. But where all 3 colors overlap in the middle, you actually see white. So it turns out you can trick the human eye into seeing white light just by shining red, green, and blue light all together in one spot. Okay, so I'm going to turn the lights back on, and we're going to discuss the physics behind this and why we see what we see here. So let's break down what we just saw. Well, we're going to start by looking at the human eye. And the way the eye works is light from our surrounding environment is going to enter our pupil, which is the dark spot in the front there. It's going to pass through a lens, and the lens will focus the light so that the light shines back here at the back of the eye, which is what we call the retina. And so the retina of the eye actually has 3 specialized cells that are basically determining what colors are around us. But the problem is we only have 3 light detecting cells. They come in the red variety, the green variety, or the blue variety. So these cones, these specialized light detecting cells, they can detect red light, green light, and blue light, but they don't detect other wavelengths of light. So they're just detecting light in these very specific zones. And so what that means is if red light enters our eye, so if there's a red object and light's reflecting off that object, it will activate our red cone, and that tells our brain, hey, we're looking at a red object. Or if a blue object reflects light into our eye, it's going to activate the blue cone, and that tells our brain, hey, we're looking at a blue object. And of course, if a green object is reflecting light into our eye, and it passes through and activates the green cone, we know we're looking at a green object. But what if we see a yellow object? Well, remember what happened when red and green mixed together with our lights? That produced yellow. So if yellow light enters our eye, it actually activates the green and the red cone simultaneously. And when those 2 cones are stimulated at the same time, our brain interprets that as yellow. Just like when we see red and green light, we naturally see yellow in our minds. So yellow light can activate both of these cones at the same time. But what's interesting is if a banana is yellow, the light from that banana activates these cones, and so we think the banana's yellow. But is that banana really yellow? Because it could just be red and green, right? What if a banana is just reflecting red and green light, and that light is passing through our eye and hitting the red and green cones? Well, our brain cannot tell the difference between something that's shining red and green light or something that's shining or reflecting pure yellow light. We have no idea how to see the difference. Either way, if an object's reflecting red and green, or if it's reflecting yellow, our eye and our brain will interpret that object as yellow. So how do we know what light is really reflecting off of a banana? Well, we have to use specialized scientific instruments to make that determination. And likewise, if another object that is brown or some other color, orange, whatever, what have you, when that light enters our eye, it's going to stimulate 2 or 3 of these cones in various intensities, and based on how our brain interprets that stimulation, we will be able to tell if that object is, red, green, yellow, blue, indigo, violet, you name it, right? So all we need are the red, green, and blue cones to see all colors. Just like with just red, green, and blue light, we can actually see all colors of light. And so that brings us to how LED TVs work. If you think about an LED screen, whether it's your phone or a television set or your iPad or whatever it is, think about what kind of light bulbs need to be in that screen. Well, you have thousands and thousands of little bulbs, and every single one of those bulbs that's flashing light at you from your screen, they're either red bulbs, they're green, or they're blue. And we know that if all of these lights activate at the same time, we're going to see white on our screen. If the red and green activate simultaneously, we see that as yellow. So if we want to produce yellow on a screen, we just shine both of these at our eye at the same time. And if the green and blue shined simultaneously, we would see cyan. And of course, if the red and blue simultaneously shine at you, you'd see magenta. And to create all the other colors, all we do is adjust these intensities from the LED bulbs in our screens to produce orange, to produce anything else you can imagine. So just 3 light bulbs are necessary to produce the whole spectrum of light. Thank you for watching Phantastic Physics. Please like this video and subscribe to our channel if you want to see more interesting physics content. Goodbye for now, and remember, it's a fantastic universe out there, so stay curious.